Okay, I think I'm live. Give me just 1 second. Also, I don't know if I like this song or not. Let's just move on to the next one. I don't even know if people can hear the song or if anyone's here at all to begin with. But hello, wonderful people of the internet. Welcome back to another episode of Leos Labs. It's been a hot minute since my last stream. In fact, it's been an even hotter minute since my last YouTube video. It's been a long time, guys. It's been a while. 112P1, hey, how are you? I hope you're having a great day. I usually stream on Twitch. I decided to stream on YouTube for a bunch of different reasons. I don't know. I just thought, YouTube now has this feature where it kind of separates the live videos from the normal videos, and I thought, why not? Let's give YouTube a try. So to that end, this will actually be the first live stream on YouTube that will remain public after the stream is over. Usually I kind of hide them a little bit, not because I think the streams are bad or anything, just because I just hide them. I don't know, it's just what I do. I put them in a playlist that's kind of hard for people to see. Dimitri, hey, how are you? No matter the case, it will be the first live stream in a while, and probably the first video from Leos Labs that you guys have seen in a long time. I'm going to very briefly talk about that. I kind of feel like a lot of people have seen that a while, or have what am I trying to say? I feel like a lot of people have, if you're here, you probably have subscribed to my channel, but you've probably forgotten what you've subscribed for because it's been such a long time since my last video. What do we have here? 頑張ってね。僕は、少し日本語わかりますよ。沖縄に、5年住んでいました。So I just said I speak a little bit of Japanese because I lived in Okinawa for 5 years. That was OIST, the Okinawa Institute of Science and Technology. It's been a while. Yes, do YouTube lives more often. I remember subscribing for 4D dimension stuff. Yeah, so there's a lot of reasons why you could have subscribed. So I'm just going to briefly talk about what's happened since my last video. So the very last YouTube video was, let's see, what was it? It was, I think, on four-dimensional galaxy stuff. So I did an n-body simulation of a galaxy in 4 dimensions, right? The plan there was to collaborate with a fellow YouTuber, get a nice paper out, all this kind of stuff, but that didn't end up happening, and so I kind of cut the project short and just said my failed gravity simulations. Now, at the time, what I hadn't told everybody was that, we were expecting a child in the upcoming year, right? And so in the past year, a lot has happened, right? I began working for MIT again, just because they had a project that kind of needed my expertise, and I was more than happy to help. I still worked on the Summer of Math exposition over the summer, and despite it being a summer thing, it is something that lasts all year. It takes a long time for me to plan and execute properly. But yeah, the big thing was last August we had, a child for the first time. Hey, Gibbous, how are you? Everyone else, hey, how are you guys doing? I missed the very start of the stream. You didn't miss too much besides it's YouTube, so you can actually go back and check it out. But yeah, so I had a kid on August 15th of last year. And since then, it's just been really difficult to get anything out. And now I know what you guys are thinking. Well, surely you could have put videos out before August, right? Like, certainly, you could have done something. Yeah, I was working on stuff, but nothing actually came out of it, And so for the first couple months, maybe August and September, November even, things were great. But, as children get older, they tend to stay awake more often, and I just ran out of time. In particular, this last month, we started putting the kid in daycare, which is great. Daycare is wonderful. It should, in principle, get us back, 6 to 8 hours a day, depending on how long they're in daycare. But what I failed to consider was the fact that kids kind of eat everything. They will put their mouth on anything, right? And so if you put a child in a room with several other children, all of their mouths are on literally every object in that room. Therefore, every disease that you could possibly give to any child, you've just given to your kid, right? And so he got sick, and then in turn, we got sick. And then we're like, okay, that's fine, not a big deal. We bring him in daycare again. He gets sick again. We get sick again. And so then, okay, fine. We do it a third time. He gets sick. We get sick. And so basically for the past month and a half, 2 months, I've just been consistently sick for I don't know, I've not been able to have a single free hour of work time just because between either throwing up or running to the bathroom because of some reason or another, or helping my kid out or helping my wife out or something, I just have not had time to get anything done, right? And so this live stream is in part an accountability stream, just so I can get back into the swing of things, start making content again, and really just start going back to the old Okinawa era where I was streaming every day and able to produce some sort of content. And again, the reason I want this to be live afterwards, and I want people to be able to look at the videos afterwards, is because I really don't know what time zone I'm going to be able to stream on. Probably around this time every day, but I can't really be sure. It just depends on when the kid's in daycare. I certainly can't stream on weekends. There's a lot of limitations to what I can and cannot do. But I thought to myself, okay, hey, let's just go ahead and give it a shot, and just start talking through some of the problems that I've had, and hopefully you guys will enjoy the content. Congrats on the child, thank you. I feel like it would be poor form for me to drop my usual off-topic personal life update right at this moment. No, if you want to update, go ahead. I obviously don't mind. And for the record, anybody who might be here from YouTube, you're not used to live streams, you aren't used to the Laos Labs live, whatever this thing is. I totally understand. Feel free to come in, drop a comment, talk about whatever you want to talk about. In general, I kind of treat the live streams as more or less an office hour. So if you guys have specific questions about, life, liberty, the pursuit of open source software, anything math related that I can actually answer, feel free to ask. Maybe stuff about PhDs, academia, all this kind of stuff. On that note, I might as well explain a little bit more about the absence, because again, the last video I put out was, again, December 2021, so it's over a year and a half, about a year and a half ago. And the last video, I kind of said, near the end, I said, I want to find a way to basically show off the research that I'm doing in a very live, public fashion. Like, I want people to be able to engage with research. And I feel personally, and I know obviously I'm going to feel this way, but I feel personally that one of the big things that we as researchers, or we as, I don't know, not intelligent people, I'm not going to say I'm smart, but we as people who are able to push the boundary of human knowledge need to do better at. One thing that, researchers need to do better at is, making that research public facing, making it so other people can understand the research, not only at a, level, like, let's say high school level, right? But also like taking people who are at a high school level of education and having them understand things that are more complicated that would usually take maybe a couple of years of undergraduate to understand. I feel like, what criticism are we talking about? That's not a criticism, for the record. I'm not sure if you're criticizing me or not, but yeah, feel free. I'm more than happy to read off chat and talk to people and all that kind of stuff. It's just been a while since my last stream, and it's just tough. And so on that note about like researchers needing to do better at providing public facing just information, better at public relations, better at science communication, all this kind of stuff. Oh, top chat ate your message. Oh no, let me try a different chat. How do I do that? Live chat. I feel like post it again, because maybe I don't understand how YouTube chat works, which is totally fair. Sorry about that. I'll keep it on live chat from now on. No matter the case, yeah, I was just going to say that there's a couple different ways in order to provide research to the public, right? So there's the one way where you just talk about the research you're doing. And I think probably the best channels that do this well are like maybe Smarter Every Day, Mark Rober, the engineering tubers, like I would say Stuff Made Here, I think is the channel name. I always get Stuff Made Here mixed up with How to Make Stuff, but there's a bunch of channels that make engineering videos and they discuss how they made the stuff that they made. And frankly, that is one very good way to do it. I mean, these channels see massive success. Another way to do it is kind of the 3 Blue 1 Brown route, or the Veritasium route. It's kind of, I know I shouldn't be putting them into the same category, but in some sense they are. They're kind of talking about research that other people have done and making it more like, how do I put this? Making it better for like the general audience to understand, right? They take something and they really explain it one step at a time, right? And these guys are great as well. But then there's other strategies, right? And the strategy I've really been honing in on, one that I really quite like a lot, but I think a lot of people probably don't like, is a strategy I call the Pixar strategy. Because every time Pixar puts out a YouTube video, every time Pixar puts out a new movie or something like this, it comes with a host of academic papers that explain how they did the thing that they did, how they made this new thing in 3D, right? And they're really pushing the boundary of what you can do in that field, but it's kind of like, it's not the point of the video. The video is something that you can understand intuitively. You like it, you watch it, and then afterwards you think to yourself, oh, how did they do this particular thing? And then you start really digging in further. And I've been really wanting to explore this way of doing research where there is a very public facing thing, like a really interesting video that anybody can watch and anybody can understand. But there's a really rich technical like backbone to it, right? And I realized most of the people that watch this channel probably care a lot about the technical backbone, because obviously you're watching a channel that has like, a lot of educational content and all that kind of stuff. But I don't know, I'm getting kind of, I'm not sure I'm willing to make super technical videos anymore. So I said, okay, let's just do some kind of technical live streams where I show off what I'm doing and why I'm doing it, all that kind of stuff on stream like I used to do. And hopefully we can make both people happy, make you guys happy, and also keep me kind of a little bit sane with the new baby and all that kind of stuff. I was considering the difference between chess, .company, and LiChess, since I was getting into chess when I realized that free and open source is basically a computer veganism. Wait, is it? Okay, I do understand what you're trying to say, that open source software is like veganism in that like, there's a joke that like, how do you know how do you know someone is a Linux user? Because they're going to tell you. And it's the same joke you say for vegans and CrossFit people and all that kind of stuff. But I kind of feel like, here's my hot take of the day. One of the many hot takes I'm probably going to say today, actually, not just my only hot take. I think vegans get a bad rap for the same reason I think Linux users get a bad rap. Okay. People always say, like, vegans will always tell you they're vegan, but they kind of have to. Right? Because like, you go out to dinner and the vegan kind of has to say, hey, I have dietary restrictions, right? And then there's this long argument about like, oh, you really should eat meat, blah, blah, blah. But why did that discussion happen? That discussion happened because of a very reasonable, person trying to make very reasonable requests that they just don't want to eat meat, And the number of people that I've seen are vegan pales in comparison to the number of people I've seen who make bacon like their entire ideology. Like literally their whole like point of being is to eat meat. And the number of people who like, feel their need to spread the love of meat, I feel is way higher than the people who feel their need to spread the love of veganism. And I feel that's true for almost any niche topic. The same thing is true for Linux, right? I love Linux. I'm not going to push it on you, but I really like it. There's a reason my old channel name was Leos OS. It was Leos Open Source, because I really wanted to push open source software. I really wanted people, I just said I wasn't going to push it on you, but I really wanted people to understand the value of open source software, and it's something I really care about. But again, I do my best not to push it on you. The way I try to, I guess, turn people into Linux users is by showing them how cool Linux is and the stuff you can easily do on Linux that is hard to do on other operating systems, right? And it's just one of those things where I kind of feel like Linux users get a bad rap because they just, I don't know, people kind of pick on them. And it's like, why are you, they're not like actively forcing you to switch or anything like that. You're just so in your own sphere that when you see something else, you kind of like naturally attack it, That one worked. 3 Blue and Brown makes advanced topics approachable. Yeah, I think that's true. There's a reason I like working with Grant, and I still work with him very regularly. He's a good person, and the content he makes is great. AI research or all research? AI research are the worst. The results are nigh impossible to replicate, let alone know the model. That's kind of true. I mean, everyone knows at this point that there's like a big AI push, at least in the public side, like, there's ChatGPT and all this kind of stuff. And everyone's asking things about AI that people have not asked since like, I don't know, I'm going to say the 70s. I mean, AI had like this big boom in the 70s, and then it kind of died off when we realized we didn't have the computational power to actually back up the AI. And now that we have the computational power, all of a sudden, all of these things that people knew about from like 20, 30 years ago are now coming to fruition. People are able to use this technology, and people are just using it everywhere. I mean, that's the problem with a lot of research papers that use AI. It's like an application of AI, not necessarily like a useful thing. It's like, this is, I don't know. I'm not saying that AI is not advancing. It is. There's a lot of really cool advances. But it feels like most of the papers I see are just using AI in this new thing, using machine learning in this new thing. And it's not so much how do I put this? It doesn't feel as novel as if you would have come up with a new theorem or something like this. YouTube apparently doesn't like the V word or anything resembling links. I might be able to fix that. I'm not entirely sure. I also don't know what the V word is. I'm actively attempting to switch to Linux and things like that. For the record, I'm not pushing it. I like Linux. I'm not saying you have to use it. I won't be able to stick around, but I'm excited to check it out later. Yeah, that's one nice thing about YouTube. This should be public afterwards. You can check out the VOD, play it back at 2x speed if you need to, all that kind of stuff. Partitions are hard, and I have an NVIDIA card, so It's being a process. Yeah, so NVIDIA is only hard if you choose to use the open source drivers. If you use the NVIDIA binary blob, which I know a lot of people will tell you not to because they're Linux enthusiasts and you should use open source software to its fullest extent. But honestly, the NVIDIA driver is pretty good. I recently switched to AMD, and I have to say the NVIDIA driver is actually a bit cleaner than the open source AMD blob. It's not a blob, but the open source AMD driver, in that it just works nicer, you know? It's being a process. What are some things that are easier to do on Linux? Pretty much any install process of software, I would argue, is easier to do on Linux, in that you have a natural package manager that kind of does all the work for you. Case in point, there was one day that we had to use HDF5 on Windows. Now, HDF5, for those of you guys who don't know, is a multi-dimensional file format. I don't know exactly the best way to put it. It's basically a folder structure inside of a file format that you use to compress things. It's very commonly used for a load of different scientific applications. It's just, you will probably have run into it if you do some form of scientific computing. On Linux, it took 10 seconds. I literally was just like sudo pacman install, done. No, I didn't have to think about it, right? On Windows, I literally spent, I don't know, it must have been like 5 hours with my friend trying to get this installed. And we were just there the whole day trying to get this thing installed. And it just really got me frustrated, you know? Like, there's just things like this that, with Linux, it's just like 2 seconds, you're done. Sure, you have to get your hands dirty with the terminal, okay, but at least it's easy to do, you know? Whereas with Windows, sometimes I can't figure out how to do it at all. And some of this is because I've been using Linux basically since I've had a computer, so of course it's very intuitive for me. And, you know, using a terminal is incredibly unintuitive for people who are coming from a Windows background or a Mac background, and I very much understand that. But I would say as a programming tool, Linux is just easier to set up the things that you need. There are other reasons I like Linux, but a lot of these are more like personal taste as opposed to actually like fundamentally easier. Most of it's just setting up a user environment and stuff. Let's see, what do we have here? Have you had time to play around with ChatGPT, Stable Diffusion, and other stuff? Made anything fun with them? No, I haven't been. So when it comes to ChatGPT, all this kind of stuff, and I don't want to go too far into this. I mentioned this earlier in stream. I really do want to make sure the stuff that I'm providing for you guys, the audience, but also like, you know, my own researched audience, if I have such a thing. I want to make sure the stuff that I'm putting out is new. It's stuff that people haven't done before. And like, you know, there's two different things that are new, right? Like, who is it? Not Mark Rober. Who's the guy? Oh my gosh, how am I forgetting his name? He's like the funniest guy on YouTube. He's an engineering guy. He made like a robot that peed beer. You guys probably know who I'm thinking of. Michael Reeves, that's the guy's name. He has some of the funniest videos on YouTube. And it's all really cool, interesting, novel stuff. But it's not like groundbreaking. It's not like, you know, new research type of stuff. It's something that if you watch it, you're like, ooh, that's really cool. I really like this guy. But that level of new is different than the level of new that I'm thinking of, where I should probably be calling my stuff novel instead of new. The problem is, novel stuff is not necessarily entertaining on YouTube, so it's kind of hard to do. And with the ChatGPT stuff, I mean, there was a time, I hit the microphone, sorry about that. There was a time maybe a few months ago where I thought, ooh, I would love to write a book with an AI co-host or something like that. That would be really cool. But now that ChatGPT is such a common thing, it just kind of feels a bit moot nowadays. It's like, man, it's already been done. It's not something that really pushes boundaries in any way. And I know that's my own fault. Like, I really should have like capitalized on the AI train like 5 years ago, but I didn't. And now we're in a situation where a lot of the cool AI things that you can do are just like applications of AI, or like really, really deep in the weeds to stuff that I don't understand. I remember a lecture by a doctoral candidate saying that he routinely ran out of Google Compute training some CNN model. In the end, he just used pre-trained ones. Yeah, I mean, I'm actually questioning why he's using Google Compute to begin with. Why is he not using like an HPC or something like that specifically for neural networks? I mean, don't get me wrong, like Google Cloud is fine, but when it comes to scientific computation, it's really not that great because the internode communication cost is like insanely high, you know? Anyway, that's my own rant. I'm sorry about that. But yeah, there's a lot of stuff like this that I just don't understand because I'm not super deep into the AI weeds anymore. Oh, they don't like talking about vegans. What? For an AI, I saw lately a new paper called The Forward Algorithm from Jeffrey Hinton. What is a forward algorithm? Now I'm interested. I have to look this up. 1 second. Oh my goodness. Anytime people send me a link to a new algorithm, I'm like, oh, of course I'm interested in that. Let me look this up. And then I look at it. It's like, it's not. It must be the AI, the archive paper. Let me check. So I have the forward algorithm, some preliminary investigations here. Let me just pop this over here. And let me do this, I believe. There we go. Oh, maybe I should change my face to be a little bit. 1 second. This is going to be harder than I thought. And you just need to move this up a little bit. There, perfect. So this is when you're talking about the forward algorithm, some preliminary investigations. Oh, YouTube video about it. Oh, I see. 1 second. The aim of this paper is to introduce a new learning procedure for neural networks and to demonstrate that it works well enough on a few small problems to be worth further investigation. The forward algorithm replaces the forward and backwards passes of backpropagation by 2 forward passes. Oh, this is quite interesting. One with positive, i.e. real data, and the other with negative data, which could be generated by the network itself. Okay, now that's a claim that I'm not sure, but a double forward pass auto differentiation instead of a backward pass auto diff. I mean, that's cool. I mean, people are interested in that. That sounds really interesting. Each layer has its own objective function, which is simply to have high goodness for positive data and low goodness for negative data. The sum of the squared activities in a layer can be used as the goodness, but there are many other possibilities, including minus the sum of the squared activities. If the positive and negative passes could be separated in time, the negative passes could be done offline, which would make the learning much simpler in the positive pass and allow the video to be pipelined through the network without ever storing activities or stopping to propagate derivatives. My only question with this, and maybe Lupo, you can answer this, is how. Right, my question is how strong is the claim that you can use the network to generate the negative data, right? So this claim, negative data, which could be generated by the network itself, I have a feeling that somehow the generation of the negative data would be the problem here, but maybe I'm wrong. I don't know. I'm just now getting into auto diff stuff. So maybe the real reason I haven't been into AI and stuff is because I just haven't, I haven't really gotten that deep into the literature, just an observer. But yeah, so for those guys, the reason I thought this was interesting is because auto differentiation, I don't know how to put this. So basically, you write code, right? That code sometimes needs to be differentiated, right, for various purposes. Yeah, maybe you need the energy from a force or something like this. I don't know. You write down the force, you want to get the energy from it. The energy is a derivative of the force, right? Sometimes you don't know what the energy is, or you can't analytically derive it. And so what you'd like to do is just write some code and have that code be automatically differentiated by, I don't know, some pre-compile flag, not flag, but some sort of, I don't know, like some sort of code rewriter or something like that, right? And nowadays, this is something that people can do. It's called enzyme, Julia. But this, you could have done this before, but enzyme is probably my favorite one because it does it at the LLVM level, and there's a lot of languages that rely on LLVM, so you can just do auto diff at that stage, and it's really cool. It means that you can do it in Rust or C++ or Julia or literally any language that relies on LLVM. You can just automatically do the differentiation. But maybe I'm right. I'm not familiar with AI. What is negative data? So that's also something I'm not so sure about. I thought the data here would be like, maybe I'm misunderstanding. I thought it was like a data set. Yeah, actually, maybe I don't understand it super well because I was imagining you have a data set and that you somehow get a negative of the data set. But when you're thinking about auto diff stuff, typically you think of like like some sort of function, like I said before, that you want to differentiate, right? In which case the negative would be the negative of the function. And so I don't understand how you generate it via the network. Yeah, maybe I don't understand. You're right. Maybe I'm talking like about stuff I have no clue about. This is not the auto differentiation related to the ring. This is not the auto differentiation related to the ring of dual numbers. To be honest, I'm not sure. I'm not. I know that dual numbers have play a role here, but I don't actually know enough to be able to go further than that. I've been mainly on the systems end for this particular thing. The wrong answers. It's the stuff you don't want. The wrong answers. Oh, okay, fair enough. If that's what the negative data is, or is it implemented that way? This is a cat. This is not a cat. Yeah, I guess that's what it is. Let me get some water. Yeah. Anyway, I might just go ahead and start on some of the stuff I want to get done today. Give me just 1 second. I will be right back. Someone in the other room was calling. Never mind, I was wrong. There is no one in the other room. I just thought that I don't know what I thought. I'm so sorry about that. Anyway, I hope everyone's having a great day. But I think I might just go ahead and get started on what I was going to work on today, which is a brief discussion on kind of some changes that have been happening to kernel abstractions and all this kind of stuff that I missed in the past month because, as I said before, I've just been incredibly sick. Like having an hour of free time in a week was basically impossible for me. It was not something I had. And so because of that, I just missed a lot of updates to kernel abstractions, and now I have to update all of my code, and it's just a mess. So I figured let's just go ahead and do a stream, talk about everything that needs to happen, and just kind of go from there. So I don't know if people know what kernel... I clicked the wrong button. I don't know if people know what kernel abstractions is, but I'll kind of discuss it here, explaining kind of how it relates to heterogeneous computing, all this kind of stuff. Example of negative data is ugly extra fingers, what we do not want in generated portrait. I feel like the extra fingers, how does that count as negative data, right? Like, okay, maybe I just don't understand. Because to me, like an image is literally just an array of RGB values, right? And so what would a picture with extra fingers actually mean to a neural network, right? Like, how is this negative? I don't know. Maybe I just don't understand it. But it is something to think about, I guess, you know. Anyway, I'm playing chess puzzles on light chess. Enjoy the chess. Okay, so let me go ahead and open up kernel abstractions. I believe I already had it up over here. 1 second. What am I doing? There. Perfect. Okay, so who here in chat knows anything about GPU computing? If you do, please raise your hand. I'll go ahead and wait, see if anybody has any experience with GPU computing. Okay, perfect. No one has raised their hand, which means I have a lot of discussion to have here. Who here knows what a GPU is? We talked about it before with NVIDIA cards and AMD. Hopefully people know what that is. But anyway, so the reason I have to talk like this is because, you know, when you talk to researchers, right? Researchers have very specific knowledge in very specific areas, right? And so what ends up happening is they know a lot about one thing, but then when you start to deviate off of that thing that they know about, it actually quite quickly, I guess, crumbles down or something like this, so that they don't really understand so much about another topic, right? And researchers will deal with this in different ways. Some people will just openly express, hey, I don't know anything about this biology thing, or I don't know anything about this computing thing. Some people pretend they know about this thing only in as much as to get through the conversation, because they don't actually care about that thing. Most of the work that I do, even when it comes to my most recent video, the failed gravity simulations, has to do with GPU. It has to do with general purpose graphics processing unit computation. And that's kind of what I do in my everyday work. It's what I do for most of my YouTube videos. It all has to do with this one thing. I don't really talk about it too much on YouTube because, frankly, it's not something that people tend to care too much about. It's like if you have a chance to talk about math, or you have a chance to talk about how to write code, on the one hand, you could make the video on how to write code and it could do particularly well, but it's not as like catchy, you know, as like, you know, Euclid's Orchard or something like this. It's just not as engaging in a way because there aren't as cool visuals to make about it. And it's really difficult to make that type of content just engaging and watchable and stuff like that. Okay, so on that note, when talking about GPU computing, I tend to like talk at kind of a lower level. Like I started very low, very basic, talking about like what a GPU is, how it works, why it works that way, with the assumption that even if you are a researcher in the field and you know stuff, sometimes, you know, you might not know this particular thing. And hey, we're on YouTube, so, you know, you can just like skip this part if you're watching the VOD. You don't have to watch the next bit if you already understand how this works. I did some NVIDIA program compiling, made some examples. We should type negative prompt for extra fingers. So in the generated picture, it will be just 5 fingers on the hand of the person. Yeah, I guess my question with that wasn't so much, okay, we know that too many fingers is a bad thing to have, right? So that could be considered negative data. But I guess how does just a single negative number, a negative value in the front of that, I guess, node in the network or whatever, represent specifically fingers are bad here? Like 5 fingers are bad, as opposed to 2 heads or 3, I don't know, arms or some other thing that could potentially happen. You know what I mean? Like I was trying to figure out how the fingers itself. Yeah, this is maybe my understanding of neural networks are not as great as it should be. Okay, so what I'm going to do really quick is I'm going to open up a new terminal and I'm going to open up Zernal PP. So Zernal PP. I'm going to move this over here really quick. And then I'm going to move it over there. Perfect. Okay. So in case you guys don't know, a GPU is a graphics processing unit. It's a thing on your computer that basically displays graphics. So if you have some sort of screen, right? And this screen is, let's just say, 1920 by 1080 or something like this, you have, roughly 2 million pixels on your screen, right? The GPU is a particular processing device on your computer that is basically tuned to generate as many pixels as possible as quickly as possible. So if you're able to do HD video at 60 frames per second, that means that you have, of the 2 million pixels, they're all changing relatively rapidly, every 60th of a second or something like this, right? And so the GPU is kind of tuned as a device to basically do as much computation as possible, as quickly as possible. But because it's basically just pixel flipping, and admittedly, this isn't what modern GPUs are for, this is kind of more of a historical point, because it's basically just like pixel value flipping and stuff like this, each individual unit of a computation is not necessarily very strong, right? So what ends up happening is the GPU, as opposed to the CPU, was built up as a massively parallel computational device, whereas the CPU is built up as something that can do like, a lot of computation, or like a very strong piece of computation. The GPU is built up as something that can do a lot of weak computation at once, if that makes sense. So what you tend to do when you do GPU computation is you tend to take something that some sort of unit of data, and you distribute it so that like each individual unit of data is dealt with like one GPU thread, and you try to make sure all threads do the same computation at the same time. For the purposes of this particular conversation, we don't have to dive deeply into what each kernel does or how it works or all that kind of stuff. We can talk about that later. For now, I just want to talk about the GPU vendors that you probably have available to you. So you probably have seen NVIDIA, probably should have done it in green, but I didn't. AMD. There's also Intel nowadays. And then there is Mac, which is Metal, I believe is what it's called. Actually, Metal is the API. I actually don't know what the actual hardware called? I'm not sure. Mac, Apple, whatever. I'm just going to put Apple over here. Right. So all of these guys have different, software-based APIs that allow you to access the hardware to do the computation, right? NVIDIA, AMD, and Intel can all be accessed via something called OpenCL. Metal and Apple, I believe, has a separate API, and I'm not entirely sure how that one works. NVIDIA specifically has something called CUDA, which Lupo brought up earlier, and AMD has a CUDA variant called ROCm. Now, Intel, I'm not entirely sure, but I do believe has a separate GPU computation pipeline, which I want to say is called Beignet, but I'm not entirely sure. The point is, all of these guys have different ways in which you can interact with them, right? Now, if you go ahead and write code for a video game or something like this, like you're going to use, OpenGL, or maybe what does Windows use? DirectX or something like this. You run into a situation where like you don't really have to think so much about the vendor itself, because these are layers above. The code you write at that level kind of will boil down into any type of GPU you want, right? If you don't define, wait, what do I have here? If you don't define the thing you don't want as output, wouldn't all output be valid? Also, the annoying part with NVIDIA is that I want to use Fedora, but it doesn't ship the drivers by default. Yeah, so that's true for most Linux distributions. They don't ship the NVIDIA drivers by default. They ship with Novo? I don't know actually how to pronounce it, but the open source drivers instead, just because, again, people prefer open source if they can use it. They used to have AMD GPUs in the Intel Macs, but now they have their own designed GPUs in their SoC, I believe. Yeah, that's what I meant when I said Metal and Apple. And actually, to be fair, before they had AMD, some iMacs, for example, had specifically NVIDIA cards. We actually used to have an NVIDIA iMac in the unit at the Okinawa Institute of Science and Technology where I worked. So Apple has been slowly but surely making their own hardware ecosystem, which is fair. An operating system without graphics drivers is not super usable. Yeah, I mean, I agree with you there. Okay, so my point here is that, like, in general, when you write code, you want this code to run on basically any hardware vendor you want. However, when it comes to GPU, general purpose GPU computing, the type of stuff where you use graphics processing units to do like any type of computation, really there's only one solution that kind of works here, and that is CUDA. CUDA is king of high performance computing, general purpose graphics processing unit computation, because it's just slightly easier to use than OpenCL. It came before ROCm, which is AMD's solution. And so people just use it. And CUDA is what people use for high performance computing. And now that everything is parallel, and in particular, everything is like massively parallel now with high performance computers also using GPUs, we're at like levels of parallelism that, you know, it becomes harder and harder to think about the base level of parallelism for a single GPU, because you start thinking about not only single GPUs, but now distributed parallelism. It becomes a mess, right? So people just stick with CUDA because it's what they know and it's what works, right? So with that said, kernel abstractions.jl, ka.jl, which is what I'm going to write here, is basically a single API that is meant for GPU, that boils down to CUDA when it comes to NVIDIA GPU, but also boils down to ROCm for AMD GPUs. And it boils down to whatever Intel has for Intel GPUs. I think it's a one API, I'm not entirely sure. And then there could in principle be one for Apple as well. And so essentially what it is a single Julia package that gives you CUDA, that gives you ROCm, that gives you Intel, gives you all of these things. It's kind of like OpenCL in that it kind of can work on any hardware. It's just that it boils down to the hardware specific code that works best. You know, for example, NVIDIA gets CUDA, AMD gets ROCm, all this kind of stuff. So the idea here is that it's just a single library that works really well and allows you to write a single piece of code that executes on whatever type of hardware you want. Okay, so with all that said, kernel abstractions is a really nice tool. It's something that I use all the time. I actually really enjoy using, but it is new. It's not something that people have been using for over maybe 5-10 years. In fact, I don't think it even existed 5 years ago. Because of that, the API does change a lot. And over the past month, there were a lot of changes to the API, some bigger, some smaller. And so today, I just kind of want to go through those changes, fix up some old code, make sure the code that I currently have is working, and then kind of reintroduce a fractal animation engine while I'm fixing up the code so that it will run the examples again and all this kind of stuff. Because not only do I have to update to the latest version of kernel abstractions, but I also want to update to the latest version of Julia, which is Julia version 1.9. Let me get a little bit more water. Also, it's been, I don't know, this might not be like super interesting for everybody. I do understand that. Again, part of the reason I'm doing it here on YouTube instead of Twitch is so that if people do want to watch the VODs, they can kind of skip through the parts that aren't super interesting to them in particular. But if you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Outside of that, I think I'm just going to go over here. You guys should be able to read everything. So let me go ahead and do CD project, Simuleos. We're going to go over here, CD project, Simuleos. I think this side terminal over here might be a little bit small, but it's okay. This is just going to be where I put the Julia REPL, so you don't have to read this one too much. This one should be readable, I think. I wish I can contribute. I barely even have a GPU, let alone CUDA. So to be honest, one nice thing about kernel abstractions is that it works on parallel CPU as well. So if you don't have a GPU, or you only have a CPU for computation or whatever, it also works in parallel on the CPU. And this is something that I think a lot of new programmers don't understand. Like when you're learning to code for the first time, a lot of people kind of, they gloss over parallelism. They kind of pretend it doesn't exist. They say, oh, here's a for loop. Here's, the basic constructs that you're going to need for code. Even when you talk about like complexity notation and stuff like this, a lot of times people ignore parallelism, right? Because, I don't know, a long time ago when people were considering computers, it was easier to just ignore parallelism. But nowadays, I don't know. I mean, who has a single core device? I mean, pretty much nobody does. Even phones nowadays are actually, I don't know how many cores phones have, but I think they run with ARM architecture, which might be a bit different. My point is, you got to deal with parallelism at some point, specifically if you want any type of performant code. So you really have to just bite the bullet and deal with it in some way. The easiest way is probably SIMD, single instruction multiple data. To be honest, I don't really think about the acronym too much, but the point is you take a single array and you basically have each individual thread deal with like an individual element of computation, and that's how you deal with it. It must be this tall to write multi-threading, I think is the reason why. Yeah, so I just think if people would deal with multi-threading as a core component of the language, like if people would think about parallelism when they're learning to code to begin with, I don't think it has to be this thing that's super scary or super hard for people to understand. I think it's something that people can understand intuitively. But because they don't learn it until like halfway, like in fact, some people don't even learn it in their computer science curriculum at all, depending on their curriculum and how like, I guess, mathy it is. You just run into these situations where like a lot of people don't understand it and they struggle to write parallel code, but that's just not acceptable in 2023, you know? Unless it's a strong, immutable XOR alias check, it's really hard to not write bugs. Yeah, it depends on how the API holds your hand, right? Okay, so let me just go here. I'm going to CD into GPU because I'm gonna have to update some stuff. So CD GPU here, and let me just go ahead and clear this terminal and also clear this terminal. I'm gonna go ahead and show what a vector addition looked like in the previous kernel abstractions API. And hopefully I'm going to update it and make it work with the new kernel abstractions API. And if I can, then I'm going to basically put all these changes into the fractal animation engine. I'm going to talk about what that is because I think a lot of people here watching the stream right now probably don't know what it is because I just haven't talked about it. So I'm hoping this upcoming thing will take maybe 5 to 10 minutes. And then I can spend maybe 5 to 10 minutes talking about what the fractal animation engine is, what I plan to do with it and stuff like that. And then hopefully we'll get some changes done, get the updates done, and then we can actually get to work on it maybe tomorrow, right? I'm hoping to do daily streams, but like I said earlier, you know, with the new kid and, you know, I'm not entirely sure how long he's going to be in daycare every day. I'm not entirely sure when I can do these streams every day. I don't know if I can do daily streams, but what I will say is I'm going to be trying to make progress every day. And sometimes I'll show that on stream, sometimes I won't. And that's the best I can say right now. So I do apologize that like this might be a one-off stream. I'm doing my best to do regular streams or at least like put out regular content, but it's just hard. I just have so much else going on right now. So we'll see how things go. Okay, so I'm going to vi vector addition.jl and let me also do vector addition ka. I think is actually what it is. Oop, sorry about that. I'm dumb. I'm still dumb. I forgot how to type for a second there. Okay, perfect. So this is the vector addition for GPU computing. So there's something called Hello World. Anyone who has written code has probably written a Hello World script. It's literally just print line Hello World or whatever it is in your language. In C++, it's, you know, C ouch, whatever, you know, 2 little less than signs and then whatever you want to type and then blah, blah, blah. Is kernel abstraction something you're working on? In a sense, okay, so back when I worked at MIT proper, and I actually went into MIT and worked there, kernel abstractions was a project that I spent a lot of time developing. But now I don't know if I can say that I'm working on it so much as I can say I'm one of the top users of kernel abstractions. So I think nowadays I wouldn't say I'm actively developing it as much as I would say I'm actively using it for pretty much everything that I do. And I'm probably the guy that's pushing a lot of like stupid directions with it. Like for example, when we were working on the gravity simulations back 2 years ago now, a year and a half ago now, I was really pushing for a lot of atomic support and stuff like that. Or there'd just be bugs where it just wouldn't work on certain architecture. And there's just stuff that I suss out because other people don't know how to do it. And I have a slightly deeper understanding of how kernel abstractions works than some people. So I'm at least able to provide like a reasonable guesstimate of how the code needs to be fixed for everything to be updated. And like for the main developer, which, well, I don't know if I should say his name, the busy bee main developer actually can solve on their own. Okay, so let's talk about what I'm doing here. So when I talk about Hello World, when I was talking about the Hello World script, there is something called the Hello World of GPU computing. The Hello World of GPU computing is vector addition. It's literally just you take a vector A, you take a vector B, you add them together to get a vector C. The reason this is the Hello World of GPU computing is kind of by design. It's what CUDA set as, like, it's what everyone learns in CUDA as the first bit of code that they write. For the purposes of this discussion, it's literally just C of ij. Again, some array is going to be equal to A of ij plus B of ij. That's it. That's all it is. And you get some sort of index ij, which in this case is going to be global, which basically means it's hitting like a global memory bank in a way. We don't really have to worry about it too much, but the point is we get some indices, we add them together, A and B, to get C. That's it. This is notably missing a for loop, right? You might expect it to have like for I is equal to 1 to, I don't know, size of C1, and then J is equal to 1 through size of C2, right? You might expect this to go through the 2 dimensions of I and J. That parallelism is done outside of the kernel call in a way. What you're doing when you're grabbing ij is you're not necessarily grabbing, like, you are grabbing a software element, but you're also, in a sense, grabbing a hardware element, right? So this kernel is being executed on kind of every individual thread that you're working on. So every individual hardware thread is executing this kernel, right? And that hardware thread has its own individual thread ID, right? Some sort of individual ij. And that's kind of like some, I don't know if you could call it a global, but it's some sort of like variable that is passed into the function is by default in the function there. So you don't have to specify the kind of outer for loop, right? Everything else you need to specify. So essentially when you're writing GPU computing, just basically write it without the outer for loop and parallelize along that outer for loop. So this is how kernel abstractions used to be written. This is specifically for CUDA. So you note that I'm adding in CUDA kernels and I'm loading the CUDA library. I think this has changed. This is something I need to check on today's stream, but I'm pretty sure this has changed, so we don't have to load CUDA kernels or CUDA anymore, and we can just run it for whatever hardware you have. Now, I'm running an AMD chip right now, which means I basically need to run AMD GPU and ROC M kernels and all that kind of stuff. It's slightly different, but it's kind of the same thing. So what we do then is we create a function, vector add. Julia notation is to add an exclamation mark if you're mutating the variables, which we're doing right here. But essentially all this is a launching function. So we just make sure if size of A2 is not equal to size of B1. Why are we doing that? I guess because I wanted to make sure the matrices are square. I don't think I actually need that in there. Anyway, we say if it's an array, we do it on the CPU, and we say we use 4 cores. Admittedly, this I actually have learned recently, this is no longer 4 cores. Maybe it was never 4 cores. This is actually the number of units you want to use. It doesn't have to be 4, but it's the number of units of computation you want to use for the CPU computation. Probably 64 is maybe a bit better. And then we have, down here, we have the kernel, and it's going to be using a CUDA device with 256 threads. What you do then is you launch the kernel here. Again, there's the kernel there, with some sort of ND range, which is the number of elements that you're iterating over. Okay, as we go down, I have a test set. And in principle, this test should work on the CPU already. I'll go ahead and check that out. And then we are going to rewrite it so it works on the GPU as well. So let's go ahead and do Julia. I'm going to use 1.9. I don't have a project here, but I'm going to run T12 to run with 12 threads. I should have. Why is this taking so long? Julia, come on. What are you doing, man? Am I dumb? I'm an idiot. I know exactly what happened. There we go. Perfect. Ignore my stupid typo right there. Okay. So here's what I'm going to do. I don't think that this is almost going to work as it is. There's just one thing that has changed since last month or whatever, and that is how the computation is performed in parallel. So it used to be that every time you ran a kernel, it returned an event. And essentially what you do is you'd wait at the end of this event just to make sure it's finished before doing any tests on it or working off of that thing. This allowed you to basically launch 2 kernels in parallel, right? You could do something on the CPU while you're also doing something on the GPU. Or in principle, no, I don't know. You could run on 2 different GPUs, or there's a bunch of different hardware configurations you could run on. This has changed recently in that you can just run the vector addition here. And I don't exactly know what to do here, but I think what you need to do is you need to synchronize on the device. So I think kernel abstractions dot synchronize, and then you synchronize it on CPU here, I think is what will happen. So the idea is, instead of returning an event, you just kind of let whatever you want to happen, just happen, right? So if you want to execute, like, I don't know, 5 functions on the CPU, but it doesn't really matter the order in which these are done, or they could all be done in parallel or whatever, you just kind of run it. So you could run vec add. I could run vec add twice, for example, or 3 times or something like that if I wanted to. And all of these would kind of be executed in parallel. But now the synchronize is essentially a barrier, as you're used to in parallel computing. It just stops all computation at that point of the computational chain. So it means after a single vector add, in this case, I'm going to wait and then do the next bit of computation. I think this will work. Yeah, I think this will work. Let me just go ahead and run it, see what happens. So I'm going to include, I guess, vec add ka.jl. It should work on the CPU. Oh, CUDA kernels and all that. Let me go ahead and remove that. So I'm going to remove CUDA and CUDA kernels. And I'm going to test it on AMD GPU in just a second. Has CUDA GPU is obviously not defined because I no longer have CUDA. Try it one more time. Okay, so that did seem to pass, so it did seem to work. GPU will be my excuse to upgrade my GPU. I need more CUDA cores. So to be honest, like, I don't know how to say this, but you know Linus Tech Tips, right? And like the PC Master Race group, you know, there's a bunch of people who, like, they care a lot about hardware, and they care a lot about, like, you know, what you're running on your computer, all this kind of stuff. They build their own computers, all that kind of stuff. Like, I'm the same type of person, but I don't really care about, like, gaming performance. I don't care if I'm getting 60 frames per second on a video game or whatever. This could be because I'm running Linux, but I do care a lot about, like, the ability to do computation that I need, right? And so I've been running on a GTX 970 for the longest time. Like, GTX 970, I must have gotten 7 years ago or something like this. Like, it wasn't even the new card then, but at the time I just needed a CUDA card so I could do my research at home if I needed to, just basic testing and stuff like that before I sent it to a high performance computer. And yeah, it worked fine. There's no reason to upgrade unless you actually have to do the computation on your physical device, like on your desktop or something like that. I would argue that if you're going to be doing GPU, probably you have a high performance computing device available somewhere. Like, you probably have a GPU cluster somewhere. I don't know, maybe I'm a bit biased here in that I've always had one available, but yeah, it's kind of a hard field to break into because you need that hardware to really do anything, like, interesting, right? I mean, you could work on, like, basic algorithms and stuff like that, but you really need, like, I don't know how to put this. You need more compute devices to be able to do anything scientifically interesting, is what I'm trying to say. Now, the fractal animation engine, which I'm going to show off in just a second, is kind of a bit different in that it's more or less a computer graphics project, and because of that, it's totally fine to use just a single GPU, all this kind of stuff. If I want to start on HPC and GPU parallelized programs, what language do I start with? I was planning to start with CUDA and C++. That's actually a very good question, and there isn't really a good answer to it either. So if you want to learn GPU, right, I would argue the best way to do that is the CUDA programming guide. Let me just go ahead and give you a link here in chat. Yank here, paste here. You should be able to access that link. I think so. I don't think YouTube chat is going to break down or anything like that. This is an annoying thing to read in that it's a book, right? And books, you know, reference books are kind of hard to read. But really, you just have to get through the introduction, programming model, and stuff like that. And once you get through the first bit, it's fine. Like, this just teaches you how a GPU works at a fundamental level, right? And then when you start asking, what API should I use? You know, should I be using CUDA and C++? Should I be using Julia or something else? That's entirely up to you. I used to argue that the only real way to learn GPU computing was to do CUDA because that was just the, you know, de facto leader in GPU computing. But nowadays, I kind of feel like the GPU pipeline that's available in Julia is way better than what's available in C or C++. Admittedly, Julia, yeah, it's a bit annoying, but there's a lot of benefits to it in that the package manager kind of deals with all this, the install stuff that you'd have to do with CUDA, right? You don't have to think so much about driver issues or any of this, because literally all you have to do is add CUDA and then just use CUDA as you naturally would. And with kernel abstractions, you can write a single piece of code that works on literally any hardware, right? The problem is that documentation is lacking, so you do have to do a little bit of finagling to figure out what works. But I would argue don't buy new hardware, right? If you have CUDA hardware already available, if you have an NVIDIA GPU, use CUDA C++ just fine. If you have an AMD GPU, I would probably recommend going through Julia in this case and using the AMD GPU.jl package, because frankly, it's just easier to use than having to go through ROCm and all that kind of stuff and installing it all on your own. And if you don't have either of those, but you still want to write code that could work on a GPU, then go down the kernel abstractions route. There's a couple of other ways to do it as well, but essentially just write the code in some kernel-based language that you'll use for, just write it in a kernel-based language. It doesn't really matter what, but as long as it can execute on the CPU as well as the GPU, you're fine. OpenCL has this benefit as well. Kind of has done CUDA on Google Colab before. I think it's free. Yeah, I don't really know so much about that, to be honest. Again, I said this before, but I don't know how many people were here during that time. I don't know about the Google Cloud stuff. I kind of feel like Google Cloud is fine if you need a single GPU. It takes a while to instantiate and all this kind of stuff, but it is kind of okay. But the moment you have to do distributed parallelism, it becomes a problem. So I don't know. I don't trust Google services too much for this type of stuff, but again, I'm biased in that I've always had an HPC available to use. Let's see, what else was I going to say? There's another argument to be had. If you want to learn GPU computing, you can do something in Julia that is actually quite nice. So let me just go here, open up a new terminal, or just quit here really quick, Julia 1.9. So again, getting GPU stuff to work in Julia is as simple as add AMD GPU, because I'm using an AMD GPU. I already have this available. And then just basically creating an array on the device. So I'll show you a very simple piece of computation. Apparently I updated. No, I didn't update. Okay, I don't know exactly what's happening here. Let's do an ST. It seems fine. Okay, so if I do A using, where am I? AMD GPU here. And then I do A is going to be equal to rock array of 1s of 10. What this is doing is it's creating an array on the GPU of 10 ones, right? And then if I want to do the vector addition that I did before, I can just do it this way, a dot plus a. Now it's going to take a second because it has to precompile all of the functions on the GPU. There's some stuff it's doing in the background that it's just not telling you about. The first time takes a second. The second time doesn't take nearly as long, and I'll show you that with an at time. Okay, so now if I do an AMD GPU dot at time here, you'll see it took 0.00047 seconds. And if I keep running, that's kind of consistent. It's basically kernel launch time is how long it takes there, because adding 10 numbers is super easy. It's memory limited, 5 gigabytes. Sucks if you want to do a medium AI model. Right, that's totally fair. I mean, to be honest, the reason I updated my GPU a while ago was not because I was unhappy with my GTX 970. It's that my GPU only had like 4 gigabytes of storage or RAM. And I kind of wanted to update a little bit, so I had at least 10. So now I have a 6700 XT AMD with 12 gigabytes of RAM. It's okay for dipping your toes, but it's probably best to buy a GPU. Yeah. And again, if you don't have a GPU available, right, I would argue if you want to learn GPU computation, just find a kernel-based language that can also work on a GPU, right? So OpenScale, kernel abstraction, something like this. And you can still learn everything you need to learn and do everything you need to do. It's just you don't have to buy new hardware. Buying the new hardware is kind of a pain. You can write some really advanced code that should, in principle, work on the GPU, and then get someone else to use their GPU to make sure it works, right? So that would be my argument if you want to learn. Okay, let's see. What else do I want to say before continuing the project? I think we can just go ahead and hop in. So now I'm going to open up the vector addition, the kernel instructions vector addition one more time, and now I'm just going to make it so I can do it on the GPU. Sorry, the GPU. So I have this if has CUDA GPU thing. I'm actually just going to remove that for now, and I'm just going to say here are the GPU tests, and I'm not going to worry about it too much, just because I'm not. In principle, I should like dispatch this according to like what array type I have. I should do something saying like, you know, if we have a rock array or a CUDA array or something like this or whatever. It doesn't really matter too much. The fact is I have an AMD GPU right now, so I'm just going to load AMD GPU here. I'm going to go down here to the bottom, and I'm just going to change these to rock arrays. ROC. We're going to do the vector add, and I'm going to wait on the rock device, I believe. So let me do, it's a long line too. It's kind of annoying. Paste here. And now we have to wait. I think it's going to be on the rock device, I believe is what I'm looking for. So let's go here and let me run it one more time. Give it a second. I don't exactly know what it's doing. Okay, so it broke that time because there was a CUDA device somewhere in there that I missed. So let me just look for CUDA. Here it is up here. Let me modify this so it says a rock device instead. Okay, give it a second. Still didn't pass. Let me just make sure there's nothing CUDA based in here. There's not. So where did this break? Let's see. CUDA device not defined. That was a previous error. No method is GPU rock device. Right. Okay, so how do I do this then? Do I have to do rock device? What is this supposed to be? It's not rock device anymore? What is it? Wait, let me check this out. So I'm going to CD back. Let me open up a new terminal. I want to keep this one up. All right, let's see what we got to do. CD projects, kernel abstractions, L is here, grep-rl rock device. Okay, so apparently rock device has been completely removed. So let me just do rock. Wait, how do I do this? Is it AMD GPU dot device? Is that what I'm looking for? What am I allowed to put in here? Let me go to the kernel abstractions documentation here. Yeah, drop down a bit here, and let me look for synchronize. 1 second. Okay, so we have synchronization section, and it looks like synchronize backend. But what is the backend available? All kernel launchers are asynchronous. Use synchronize to wait. Okay, I understand that. CUDA backend, so it must be rock backend is what it's going to be. Let me just double check. So I should be able to do. What am I doing? Something backend. Find backend? No. How do I find the backend? Use backend. Let me just go to the examples here. VI examples, matmul. It is backend, load backend, that's fine. Backend, get backend. Oh, that would be impossible for me to remember. Get backend, and then I'm gonna look for A, and this should return, oh, I don't have A, so using AMD GPU, A is gonna be equal to rock array, and then get backend here. Stack Overflow error, get backend of A rock vector repeats 79,984 times. Somehow I don't feel that's right. All right, let me check for get backend over here. I feel like there might be something wrong with the AMD GPU pipeline that this is becoming an issue. So let me do grep-rl, and let's look for get backend here. VI source kernel abstractions, get backend here, perfect. Get backend, end. Oh, thanks for that. That's super helpful. Okay, let's see. These are all going to be get backend parent. Oh no, it just returns CPU. That's not what I want at all. You haven't missed too much. If you want to look back on the stream as it has been, feel free to just skip back a couple minutes. Essentially, what I'm doing right now is I'm trying to fix some. I've been having trouble getting work done in the past month due to being sick with a kid and all that kind of stuff. So I'm kind of catching up to some of the changes that have happened in the kernel abstractions library, and hopefully getting that working and then introducing the fractal animation engine in a few minutes. I believe we'll be done with this part of stream in I don't know, maybe 10 minutes or so, which I said 10 minutes ago, I recognize now. And then we can talk about the fractal animation engine and all the stuff that needs to change there. So I do believe that get backend of A is not working as it should. Let me do an @edit here. This is going to bring me to get backend of A is get backend of parent of A. Sure, that's fair. What is parent of A? Rock vector. All right. So we're running into an issue. I think get backend is defined in AMD GPU. Let me check that out really quick. So I'm going to CD back into AMD GPU. ls here, and let me do grep-rl get backend. It is not defined here. So then I have absolutely no idea how get backend is supposed to work in the first place, and I'm gonna have to contact the developers and be like, hey, what am I supposed to do here? Because I think all of the examples rely on get backend now. Oh my goodness, this is why working with a new library is tough. So grep-rl get backend. Let me just look at, I don't know, matmul. I think I looked at this one a second ago. Get backend of A. So let me just try running this. Does this work? So we're going to cd back into one more directory, kernel abstractions over here, Julia 1.9 -- project -t12. Try rock backend. I think if I do rock backend with parentheses, it will work, but I'm trying to figure out why get backend doesn't work. It's kind of a side tangent, but it should still be okay. So I should be in the Julia or the kernel abstractions project. I should be able to load. Let me look at histogram and get backend here of histogram output. So how do I run this on a different histogram test base version ran input histogram? How do I run this on a particular backend? Wait, like how do I run this for a rock array? I wrote this differently. So I actually wrote this code to put into kernel abstractions, and I wrote it specifically so you could test CPU and then GPU, because I was thinking, hey, what does a user need, right? But then what ended up happening was all of these examples turned into tests. And so now this is a test for kernel abstractions, and they said, oh, well, the tests, they feed in a backend instead of having the user define a backend. So now we have a situation where the stuff that I'm wanting from an example is not here anymore because it's been removed. And because kernel abstractions has changed, I can't just go to a previous version and look up what I'm looking for. So yeah, I have no idea. So how do I run this? So this runs with, okay, I think this is what I'm going to do. So I'm going to just do the matmul, and we're going to try to do that on an AMD GPU. So I'm going to include examples matmul over here. Perfect, that's great. Instantiate. That's okay, not a big deal. Okay, maybe it is a big deal. Active manifest file has dependencies that were resolved. A different version of Julia. Unexpected behavior may occur. So Snoop precompile is a direct dependency, but does not appear in the manifest. If you intend Snoop precompile to be a direct dependency, run package resolve. Okay, resolve. And then instantiate. Okay, give it a second, and then hopefully everything's going to be okay. We can run this, figure out what the get device mystery is, figure out why it's not working as intended, and then we can go from there. So what am I going to do next? I want to do include matmul one more time. Hopefully this will run this time. Tests passed. Perfect. We have the matmul kernel, and then we have the function matmul that relies on A, B, and C. So what I'm going to do is I'm just going to define these guys one more time, but I'm going to force them to be rock arrays. So using AMD GPU, perfect. And then I'm just going to, turn them into rock arrays and hope everything's fine. And do a matmul of ABC. And then if that works, then I don't know, I have something wrong with the other directory or something. If it doesn't work, I don't know. I really have no idea what I'm doing here. So let me get some water. At least I have a simple error with like some reproducer that I can put into the kernel abstractions, like as an issue at the very least, I'm sure it's like super simple. It's just I'm not exactly sure where to put the code. Maybe it's in like AMD GPU. Maybe it could be. So let me just see. I might just create an issue in just a second. So A is going to be equal to rock array of A. B is going to be equal to rock array of B, and C is going to be equal to rock array of C. Okay, so now we have that, and let me just do matmul of A, B, C, and let me see if this errors. It does with the same Stack Overflow error. Okay, good news. This means it wasn't just like my individual directory that was broken. Bad news. I'm an idiot and I have no idea how to fix this. So let's go ahead and check out the latest version of AMD GPU. So cd back into AMD, ls here, git branch, git checkout master. Okay, git stash, git checkout master. And now let me check AMD GPU.jl. Because what might have happened, I'm not entirely sure. It might have been that they switched from master to main recently. Sorry, I have the hiccups. They might have changed from master to main recently, which would, no, it's still in master. So let me just pull the latest master. So git pull upstream master. Okay, so I am on the latest master. So grep-rl get device. I am looking for get device, right? Get device of A. Oh, kernel abstractions. Oh, it's not device. It's get backend. Okay, it's still not there, but you know, I tried. So get backend of A. Yeah, okay. So I guess I'm just going to create the issue and see what the problem is. Okay, so we're going to go here. Let me go to the kernel abstractions GitHub repository, and let me just see if there's an issue already generated. No, it's already generated right here. You just need to be on Julia GPU CUDA. What? On Git backend coup rand 3. You need to be on the latest CUDA. That's fine. Oh, it's open. Oh, there's probably a similar one on AMD GPU then. Pull requests. 1 second. And I want to look for do not merge stable development branch. 1 second. Where did this go? Has it already been merged? Let's look at closed PRs here. Oh boy. Rock signal. Let me just look for. I'm looking for rock kernels. It doesn't look like it's there. So let me just go ahead and go over here and say, okay, stupid question. But has this already been made for AMD GPU, or does it still need to be done? What does this actually do? Dismiss? I don't care. Also, let me check to make sure the exact thing that they posted here is also the issue. Yeah, okay. Stack Overflow error. Let me just double check. Here, get backend coup ran 3 over here. So I'm gonna do, okay, I'm an idiot. 1 second. Copy this, paste it over here. Control Shift V, and I want to do, I guess, rock array. Or can I just do rock? Yeah, it looks like a similar error. Let's go ahead and paste this here. I'm an idiot. Okay. One second. Let me take a look at this PR one more time and see if there's a similar one on AMD. I don't see it exactly. CUDA kernels to CUDA. Let me comment here. I don't mind making the PR. I think I could just kind of figure out what the issue is and make it. It's not a big deal. Okay, let's see what he says. He should be quick to respond. I think he's up now, so we'll see if he responds. He might even respond by the end of the stream, but I don't know how much longer I'm going to be going today. Just because first stream back in a while. So cd back here, cd into Simuleos GPU, which is where I was before and where I am in this terminal over here. Let's go into vi vec add underscore ka.jl, and let's go ahead and modify this so it just says rock device, because I think that's going to work. So, sorry, rock backend. Okay, so here I'm going to do Julia T12, include the vec add ka. It breaks, and it breaks because I have some weird package resolve issues. So let me just go ahead and do resolve. And then maybe instantiate one more time. Could not find file package rock kernels. Could not find file for package rock kernels. Let me do st here. Maybe I should go ahead and remove rock kernels. So you remove rock kernels. And now let's try it one more time. Project kernel abstractions. Oh, I also need to make it so... Oh, I'm using the wrong Julia version. Bah, that's why. Sorry about that. That is me being dumb. Oh, gosh. Anyway, I hope everyone's having a wonderful day. I'm sorry that we kind of got deep in the weeds. I feel like we always get deep in the weeds, but that's okay. Let's go ahead and do include one more time. And then hopefully we can just run this. It'll work, and we can talk about the next bit of today's stream. VecAd failed because is GPU rock device didn't work. So let me see what we have here. Kernel abstractions dot synchronize. Okay, and we want to do, what is it saying is missing here? So no method is GPU rock device. This is going to be on line, let's see, test VecAd line 40. Line 11 actually. VecAd line 19. Oh, it doesn't like rock device is a problem. Fixing open source bugs is helping everyone that uses it. Yeah, that's kind of how I feel it as well, but it doesn't like rock device. Doesn't like rock device. Okay, let me figure that one out then. Let me go into, I don't know, I've written kernel abstractions code so much, and somehow I never get the right notation. Projects fractal animation engine. And let me do grep-rl rock device. Yeah, it's literally in all of these kernels. So, what do I do? What is get backend supposed to return, right? I know in the case of the CPU, it's CPU, you know, 2 parentheses. But what's it supposed to return in the case of an AMD GPU? Let me go and take a look at the CUDA kernels here. And let's see what, so is CUDA backend? Is it supposed to be CUDA backend now instead of CUDA device? Is that, okay, well, let's check that. So let me go into, oh gosh, guys, I'm sorry. This is just a lot of random rambling. It's kind of hard to see what's going on. So let me cd into projects, kernel abstractions, ls here. Let's go into vi, matmul again, I guess, examples. Matmul over here. And it looks like when we do the kernel nowadays, we get the back end, and then we do the matmul kernel on the back end. So that must mean that we want a rock backend instead of a rock device nowadays. So I think that has changed notationally, and let me see if that's what it needs to be. Okay, let's see if I run this, what's going to happen. Here, right, and there. Still didn't work. Rock backend not defined. Okay. Rock device is defined. Kernel vector matrix Q signal device array. I'm going to say it. I think kernel abstractions is fundamentally broken on AMD GPU right now. That's what I'm going to say without knowing what I'm talking about. So there could be a situation where like it's totally working. I just don't know the right thing to call. But the fact that I can't, so the problem here is that I need some sort of backend to run on, right? Whether that be AMD, Intel, NVIDIA, CUDA, something like this. Something, I need some sort of backend, right? It used to be that these were called CPU and then rock device and CUDA device. That's what they used to be called. However, in the new version of kernel abstractions, these have changed their names a little bit, I guess. I'm not entirely sure. I just know the kernel is not launching, right? But let me try launching this as rock device one more time. And let me see if that actually launches. So we're going to do include here. Let's see what we get the error. Probably code gets buried and nobody bothered to test it on AMD. Well, the thing is we do test it on AMD. And that's what gets me, right? Because if you go at any, let's actually go to the pull request that changed everything. So we go to, use symbols instead of values when emitting code when possible. Oh, that's an interesting one. Files changed. Let me see what they're doing here. It doesn't matter. I don't know why I even look at this. Who cares? Okay, point is, obviously we have CI, and this CI tests CUDA, AMD, CPU. It tests everything, right? And so in principle, we should have tested this, right? Oh, this is for CUDA. We want for, I'm on the wrong, that's why I couldn't find it. I'm looking for this one. Let me go to pull requests here. Let me just check the most recent closed pull request, and let me see how recent this is. So only skip histogram test on CPU. What? Backends are adapters. I have no idea what's happening here. My gosh, what is happening? Adapt to AMD. This is in February 7th, though. Where is the bump 1 API to 1.0? Rename. I don't know. Add optional priority feature. These are all breaking on CI. We've merged so much code and all of it breaks on CI. Okay, so now I'm a bit... Oh, that was me back in November. Anyway, now I'm a bit confused as to why any of this has been merged in the first place. So maybe I'll just ask the developer and be like, yo, what's going on here? I mean, I already asked here, so hopefully we'll get a response today. But I can just ask them in Slack, I guess. Get blame. Well, the problem is I think the code was removed instead of added. And because code was removed, it's kind of hard to do a get blame on that kind of stuff. So to be honest, there isn't much more I can do right now because I'm kind of waiting on... I'm waiting on the answer here. And to be honest, like continuing to like go down this route isn't necessarily going to be, it's not going to be fun for anyone. It's not going to be fun for you guys. I'm just going to end up just like rambling to myself a bit. So what I might do is I might end stream here, which I admit might be a bit of a lame stream for a first stream back, blah, blah. But also like, I got to be honest, I have not been speaking to anybody basically at all, except for my baby and my wife, because I don't really have a social circle here. So this is the longest I've had a conversation with anybody for a very long time, and I am feeling very socially awkward right now. So I might need to go ahead and end stream. Where's the documentation for this normally located? Here, I'll go ahead and show you guys the docs. But again, this is a change that happened recently. So anyway, here's the kernel abstractions docs. Yank and paste. Anyway, as far as I was laughing too, you did well, thanks. Even though I can't read the I guess kanji or whatever. I say kanji. I don't actually know what it is because my text browser isn't showing it. Okay, so here's a couple things that I want to leave the stream off on. So number one, if you guys enjoyed the stream, feel free to leave a comment now or to leave a comment in the comment section below, letting me know if I should do these more regularly. Again, I do want to do more regular streams. The question is, do I do them on Twitch? Do I do them on YouTube? Do I do maybe one stream a week showing everything off? Or do I do more like working in progress streams like this one? Tomorrow's stream will be, if I do a stream tomorrow, again, it's kind of 50-50 because I need to figure out my schedule with, my kid going to daycare and blah, 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 so many other things. But if I'm able to stream tomorrow, probably what I'll do is I'll finish up what I was working on today, getting the basic vector addition to work on AMD GPU for kernel abstractions. This might involve putting a PR forward in the AMD GPU repository, or there's a bunch of things that could happen. I'm not entirely sure, but I'm going to try to stream sometime tomorrow. Again, I'm not entirely sure. Oh, I did get a response. Let me see what we have here. It needs to be made, but first the PR needs to be completed. Oh, I see. Plan to work on it later this week. Okay, so now I have to ask a very stupid question. Oh, my word. Okay, so stupid question is... All right, another stupid question. Is KA broken for AMD GPU right now? Question mark. If so... Yeah, because I can't seem to run any kernel off of a ROC device. Let me see, what do we have here? VecAd kernel ROC device is GPU, GPU. No method for is GPU ROC device. VecAd kernel abstractions line 40, client. So what I need to figure out is... So it says it's broken in line 24. Let's go to line 24 just to make sure I'm not being stupid. Okay, well that's the start of the test set, so that's not where it's going to break. Right. So the CPU version works. Does this mean that ROC devices just don't work? How did this pass CI? I guess this was a breaking change because they had to update multiple repositories at the same time. I'm just gonna say I can't launch. I can't seem to launch kernels off of ROC devices anymore. And what's my other stupid question here? Dot. That's what I'm gonna leave it as. I'm so sorry. Some older code. Work on an older version. This is merged. Okay, another stupid question. Is K broken for AMD GPU? Okay, just my stupid question. I don't know. Maybe it's not a question I should ask, but it's a question I need to know the answer to. All right. That, unfortunately, is where I have to leave it today at a very, annoying cliffhanger where even the code I was trying to work, the very basic hello world of GPU computation, does not seem to be working in kernel abstractions anymore. Like I said, the stream title was Welp, Gan batte, because frankly, I'm sorry, I did not know if we were going to go anywhere today, and it turns out we didn't. We made some progress, we probed a little bit, and we tried to figure out what was broken. I think we found out what was broken. It just means that I might have to put off the updates, which is what I was planning to do today. I plan to do those at another time. So it's not going to happen. Not going to happen today. Instead, tomorrow, if I come back on stream and the PR still hasn't been merged, I might continue working on some fractal animation engine stuff instead, which is actually going to be more fun for everybody involved. It's just I wanted to update to Julia 1.9 and get the kernel abstraction stuff out of the way so I didn't have to think about it anymore. But that's okay. I mean, it could just be that right now everything is kind of in limbo right now, which is just how it is. It's not a big deal. Okay, that said, again, like I was saying before, if you guys have any comments, questions, concerns, anything like that, feel free to let me know. Otherwise, I'm probably going to be ending stream here. If you want me to do another stream here on YouTube, let me know in the comment section on the YouTube video when it's a VOD or whatever. If you are watching this and it's not live and you've watched the entire stream, I'm so sorry that you had to, go through the VOD, not live and all that kind of stuff. Hopefully you can catch me live next time. I don't know what else I have to say here, but I am very happy that you guys joined because, again, it was kind of like an impromptu stream at a very weird hour for a lot of people. I know time zone-wise, people in Europe are still at work. People in the U.S. are probably maybe just getting into work. People in Japan are probably sleeping by now. It's not the best, place to stream. But I will say I do enjoy streaming, and it's something I want to do more. So I'm going to try to schedule a stream maybe every day, just as a catch-up stream, if nothing else. Might not be super long, might be an hour, just to say, hey, how are you guys doing? Might treat it more like office hours. Not really sure. We'll see how it goes. But the main thing is I am doing the best thing I can I'm doing the best I can to ensure that I'm putting content out again. It's been a long time since I put YouTube videos out. The content I'm going to be making is maybe slightly different than the content that people are used to for my channel. I think that's actually a good thing, and I think overall in the long term, people will like that. But I think short term, there might be some people who are angry at my next actual YouTube video. And so in a sense, these live streams are a way for me to express the technical debt or something that I'm missing in the videos. It's a way for me to just talk about things that I'm interested in, stuff I'm working on, interesting technical topics that chat brings up, all this kind of stuff, so that the videos can be more for a general audience. And hopefully that works out a little bit. We'll see. I've got a couple videos planned, obviously, and I'm hoping that they come out. The next one will come out hopefully around April 1st or 2nd, probably the 2nd, not the 1st. And the video after that, I'm really hoping to get out on May 3rd. There's a reason for that, but I don't know if I can exactly say that reason. Anyway, this is all I've got for today. I will continue working on this in the background, hopefully getting something working by the end of the day. At the very least, I'm going to try to get something working on Julia 1.9, even if it's not on the latest kernel abstractions version. Lots of stuff to think about. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Leos Labs. Again, let me know what you guys think. Any issues there could have been in stream, like audio quality issues, anything like that. Let me know. And yeah, let's got a